Hello and welcome back to Mastering C++ Memory Features. In this and next few lectures, we will look more closely at awaitable and awaiters. In the last lecture, we already looked at how to access coroutine data in its suspended state from the caller. In this and next few lectures, we will look at how to access and modify coroutine's data in its suspended state from within the coroutine as well as from outside the coroutine. To achieve this, we need to understand what happens when the coroutine is suspended. Specifically, we need to understand the compiler and runtime system calls to functions that happen underneath during the suspension of a coroutine. These underneath calls are decided by the structure of an awaiter. We've already been using awaiters since the very beginning of our coroutines journey, namely stdsuspendNever and stdsuspendAlways. It's time to understand how they work internally. Co-await is a new keyword or new operator introduced in C++20. It's a unary operator, and the expression on its right-hand side is an operand to the co-await operator. According to CPP reference page, whenever the co-await expression is encountered during a coroutine's lifetime, the expression is first converted into an awaitable through a series of calls. And then the awaiter object is obtained from the awaitable from another series of calls. And when the awaiter object is finally obtained, the runtime system executes methods on the awaiter, namely awaitReady, awaitSuspend. Oops, I should have highlighted only the awaitSuspend here. And then finally awaitResume. In the most simple cases, awaitable and awaiters are same. SuspendNever and SuspendAlways are trivial awaiters. So now I want to show you the CPP reference page of stdsuspendNever and stdsuspendAlways. So stdsuspendNever is actually a struct with three member functions: awaitReady, awaitSuspend, and awaitResume. awaitReady always returns true, true indicating that the coroutine is ready for execution and that the runtime system should not suspend the coroutine. And then finally we have the two void returning methods awaitSuspend and awaitResume, which does nothing in the case of trivial awaiters. Similarly, in SuspendAlways, we have the same three methods in the public interface, but the only difference is that awaitReady always returns false, indicating that the coroutine is not ready for resuming, or in other words, the runtime system should always suspend the coroutine. Now I want to show you something with the code. So here we have the same coroutine as in the previous case, and the return object is factored out into a header file. The only important point to remember is initial suspend and final suspend return SuspendNever, indicating that the coroutine should not be suspended when these methods are executed. And then, there's a co-await statement which has stdsuspendAlways as its operand. And if I run the code, I see the three statements. The first statement from within the coroutine. The second statement returns the execution in the caller of the coroutine, and the caller of the coroutine resumes the coroutine via the overloaded bracket operator on the coroutine handle, which again executes the final statements from the coroutine. Now, if I use, instead of stdsuspendAlways, my own custom suspendAlways like this, and since this is a struct or class, I can instantiate this here, and if I compile it at this point, I get an error, compiler error, namely the awaitReady method is not present in suspendAlways. So if any of these method awaitReady, awaitSuspend, and awaitResume are missing, the compiler will complain. So we need to provide all the three methods. I have already done this in the commented part of the code in the header file, which I'll copy and paste directly. Now if I compile and run the code again, I get the same sequence of execution as in the case of stdsuspendAlways. Yep. So the only difference is now we have our custom suspendAlways instead of stdsuspendAlways. What is more important that I wanted to show you, the sequence of calls inside the awaiter. For that, we can add cout statements, ready, new line character. Yeah, so we add the cout statements in all the methods. I've also already done this to save time. In this file, we have the same suspend always with cout statements in suspend await ready, await suspend, and await resume method. Let me clear the console and run the file once more. Run the correct file. And now, instead of 3, as compared to the previous file, we have 6 cout statements on the console. The 3 cout statements come from the awaiter. So the sequence is, first, the coroutine starts its execution normally. It encounters the suspend always, which is co-awaited. When the suspend always is evaluated, the execution first enters await ready. Await ready indicates to the runtime system that it is not ready, hence it returns false, in which case the execution enters await suspend. The await suspend can do some computation. In this case, it only does std cout and then returns the execution back to the caller. The caller resumes the coroutine, and what is very surprising here is that the resume returns back to the awaiter which suspended the coroutine. And more specifically, the resume operation goes to await resume, as you can see by the std cout statement on the console. And then await resume can also do some computation. In this case, it does std cout and then finally returns the execution back to the coroutine where the final statement in the coroutine gets printed. So this was the sequence of execution of the coroutine when it encounters an awaiter. In this lecture, this is all I wanted to show you. In the next lecture, I want to show you a bit more details, but with std suspend never and our own suspend never. So stay tuned and keep learning modern C++.